Good morning. Good evening. Wow. Way to start off the week. Feels like morning. I feel bright and airy and refreshed. How's everyone doing? Hey, Lord Azazel. Thanks for stopping by. Sorry if it's a long day. I like the Super Meat Boy emoji. That's my game right there. We'll have to play some. We'll have to play some on stream one day. I used to be so good at it. I'm not good at it anymore. What's up, 88 Opus? Good evening. How's everyone doing tonight? Welcome to Mastermind Academy. Welcome to week 7, I believe. I think we're on to week 7, so we're making it pretty far, which is pretty dope. So welcome. Just getting everything set up here. Is everyone excited for the long weekend? I keep forgetting that. Well, at least for us here, for if your government, if your company follows government. Government holiday policy. Tomorrow is President's Day, I believe, here in the United States. So we get a nice, cool Monday off, which is going to be nice. I completely forgot about it, and I have a lot that I need to do. So it'll give me some time to kind of relax and be able to get my stuff done carefree, which is pretty nice. What's up, Angry Mohawk? How you doing tonight? All right. What is this? Clear. What was I doing here? I don't think I was doing anything here. Dope. Yeah, so tonight we have some more AWS stuff. So tonight's the last part of the core AWS stuff. Next time is the purely serverless lab. So next time we'll be focusing on a single technology or a single service that Amazon has available to it. I think it'll be pretty fun to do something like that. But we're going to focus on what is probably the least... I don't know. I don't think this part is particularly exciting, but it is at the core of AWS and kind of setting up proper infrastructure. It's something that you need to know. So we will be going over that tonight. And that is mostly networking and security and like account management and things like that. Just how to set up your services to be served. So we're going to be talking about VPCs, which is very important. We're going to spend a majority of our time probably on the VPC portion. We'll hop into CloudFront, Route 53, CloudWatch and CloudTrail. We will not spend a ton of time on those. We'll be spending most of our time up here tonight, but we'll get through this stuff and it should be pretty cool. We're going to get hands on and build out a new VPC. Let me get everyone the slides for tonight if you don't already have them. So links for the what? Got 2 links. Are both of them empty? I don't know why this keeps happening. Like, let's see. Classroom. It shouldn't be empty. I know well, we'll see here. And every time I go back in, for sometimes it is. So we'll just add it right now so that it won't be. Google Drive. This seems right, like the right one. All right, check it now. Should be updated. Is the other link empty as well? WCs. That should be good. All right. I don't know, man. I'm struggling with this Google Classroom thing. Super weird, but just slides empty for me. Cool. Yeah. Hopefully, let me know if that works or not. I'll just grab the link anyway. For anyone else who wants the slides. Let's grab the shareable link. All right, copy link. Let's get it pasted here. And there we go. Pretty simple. I need to check my schedule, but this Friday, I actually plan on doing some, Friday 21st, I plan on doing some, just kind of like a wind down Friday. Like I talked about it before, possibly doing one. This Friday, I think I'm going to do it. Just kind of office hours. We can come just chat, probably play some games, probably play some either Jackbox games or some games all of us can play. People can hop in and play together. But I don't know. I think I'll just do some light conversational streaming on Friday. If anyone's interested, if anyone wants to kind of stick around, I know people have been reaching out, asking me a lot of questions individually. I want to give people a chance in the forum to kind of get some of their other questions answered. So if you're free, probably around the same time, go as long as people are kind of chilling and hanging out. We will probably go ahead and do that. But let's go ahead and let's get started tonight, so that we don't have to take. I don't think we might not even hit the 2 hour mark tonight, which is really nice, because we're going to focus purely, for the most part, on the VPC part. This should take up most of the first hour, I think, and then we can just kind of run through everything else. So, part 3, intro to the cloud. Part 3, what a cloud is made of. Linux servers mostly. This is very, very true. Whoops, let me get my mouse down here. All right, so tonight we're going to be talking about networking and content delivery. Very important. It's interesting because networking is by far, well, not by far, but networking is definitely my weakest aspect of the entire computing stack, really. The entire OSI model, like, this is where I have the least experience. But the good thing is that the cloud gives you enough tools that you don't have to quite know as much as you would have to otherwise. So it's kind of nice when you get a software-defined networking and the way that Amazon kind of handles these things. But we're gonna talk about that and content delivery. So the very first thing we're gonna hop into tonight, which is the most important thing that we're gonna talk about, probably, well, it's not AWS's most important service or anything like that, but it is something integral to the infrastructure that you're going to be developing, that people are going to want you to set up with Amazon Web Services. And this is a VPC, or a virtual private cloud. So what is a VPC? A virtual private cloud is an on-demand, so almost every service in the cloud is in fact on demand, but it is an on-demand configurable pool of shared computing resources. So we'll stop there for a second. So on-demand configurable pool of shared computing resources. You can get it whenever you want, and it is a shared pool of resources, and it is allocated within a public cloud environment, providing a certain level of isolation between the different organizations using the resources. So look at the word itself, virtual private cloud. This is taking the public cloud and sectioning off a piece that is isolated from other operating pieces of the cloud. So it's like your own little piece of the cloud that is through networking is kind of sectioned off from everything else. That's why we have a little cage over here. And so virtual private clouds are great. It allows you to kind of manage resources in a very secure way. Allows you to more easily be able to have more important resources kind of interact and connect with each other at the same time, while keeping them safe from access from other services and things, which is, it's really important in Amazon to be able to do cool things like this. So big topic tonight, but a very simple topic, high level. It's just that it's your own little sectioned off piece of the public cloud, and it's done through networking. So it's not actually your own, I guess, hardware or anything like that. It's all done through networking, and the way that your resources and things are set up inside of those networks allows you to have your own little private cloud here. So we said that these VPCs, these virtual private clouds, they are to isolate from other organizational operations. So you can have multiple VPCs inside of your account. So in the account that we set up, the one that I'm going to log into, by default, they give you a default VPC, which is set up so that you and your services can access the internet and connect to whatever you want to connect to. So by default, you're not really isolated from from everyone else or from other things, because out of the box, they kind of want to let you be able to set things up how you need. But when we do go ahead and we create these, let's say we want to create one for the usage of just our developers, and we want to have a pool, that shared pool of resources for our developers to use inside of this networked VPC. We could have one for, one set of developers, and then maybe for our platform team or something, we could have another VPC that's inside of the same account that they could use to access things that, again, is networked off from their separate pool of resources. They're completely separate, unless explicitly told. They can't interact with each other at all. They kind of both live off in their own areas. But what if you do need this virtual private cloud to be able to talk to another one? What if you need two virtual private clouds to be able to talk? You can do something called VPC peering. Peering is great. And there's a little image of it. Each of these little sections here is its own little private cloud that was created. Each of these is a VPC that was created on its own. But a VPC peering connection helps you to facilitate the transfer of data between two VPCs. It allows two VPCs to be able to talk with each other and transfer data in between each other. So you take a look at this diagram. You can see here that it's set up in an interesting way where everything is peered. Basically, every time you see these arrows, that is the connection peering, that is the VPC peering there. You can see here that how they're all peered to VPC A. So VPC peering works in an interesting way. It works in a hub and spoke pattern. So it's like kind of like a wheel all the way around here, and we've got the hub and the spokes here. But this does not mean that all of these VPCs are connected. That is not true. All of these VPCs are explicitly paired to VPC A, but you cannot do something like this. You can't, because these two are connected, you can't say, all right, cool, I'm gonna feed data through A to get to D. It does not work that way, which is very interesting. So just kind of save this in your mind. You have to explicitly peer the VPCs for them to be able to work properly. And again, it's not transitive. You can't send them through each other. It only kind of works between the two VPCs that are explicitly peered. Why would you want to do something like this? Maybe, again, you have two different section off VPCs based on business needs. Maybe you have a whole suite of applications that does something for your marketing team, and then you have a whole suite of applications that does something for your business development team. But maybe there's some data that comes from your marketing team that needs to be fed into some kind of pipeline in your BD team. And so you may want to create a connection between those two virtual private clouds so that you can feed the data through them, so that you don't have to do any, weird thing to kind of get data across. So this is a very common thing to do. So important that you know about it. And what's up, Pylang? Welcome to the channel. Thank you for the follow. All right. So we're going to talk about some more pieces now of VPCs. Again, VPC, high level concept, fairly simple, but there are a lot of pieces that make a VPC work, and a lot of things that you are able to configure inside of a VPC to do certain things, to control certain things, to make certain things happen. So the first of which we are going to discuss, we are going to talk about a VPC, an internet gateway, an IGW, internet gateway. So what is an internet gateway? Well, an internet gateway allows resources within your VPC. So I know there's a lot of acronyms here. So again, do your best, focus on the concepts, do your best to try to break down the higher level concepts of what we're saying. So an internet gateway allows resources within your virtual private cloud, that we've been talking about so far, to access the internet, and vice versa. So by default, you will not have access to your VPC. Resources inside of your VPC will not have access to the internet, but an internet gateway allows resources within your VPC to access the internet and vice versa. So back and forth. In order for this to happen, there needs to be a routing table entry. So we're going to talk about routing tables that allow a public subnet to access the internet gateway. So this is very important. We're going to dive into some deeper networking topics here tonight, unintentionally, but we're going to have to just to kind of explain what goes on with the internet gateway. But let's take out some keywords here, or let's pick out some keywords. In order for this to happen, there needs to be a routing table entry. So remember, routing table, maybe write that down, allowing a public subnet. And so maybe write those down separately. Maybe we'll talk about what a subnet is and public versus private, because we'll have to discuss that as well. But a public subnet to access the internet gateway. So it has to be a public subnet for that to happen. And yes, the GIF is dope. Adam, it made me laugh. The first time I saw it, I was like, this is the best. And this is just a gateway here. And then, it eventually lets the person through. But yeah, that is what an internet gateway is. So we're going to get hands-on with Internet Gateway. So hopefully you get the high level. Just, you don't even need to understand what it is right now. Just take those words in, start to churn through them, start to let your mind process what it's talking about there. So next piece of an Internet Gateway, of a VPC, of a virtual private cloud, is a NAT gateway. So none of these things are actually essential. You do not have to utilize any of these things depending on what your use case is. They're just commonly used pieces of VPC, again, that you can use to make certain things happen. Again, like the last thing, which was the Internet Gateway, it was allowing your resources to have access to the internet and vice versa, which means the outside internet have access to your resources. So what is a NAT gateway? NAT, first off, is an acronym for, I believe, Network Address Translation. Let me confirm. What does NAT gateway stand? Network Address Translation, perfect. I was pretty sure of it, but again, we just want to check to make sure. But what a NAT gateway does, it allows resources in a private subnet. So we just learned about, we just heard the term public subnet. Now we're hearing the term private subnet, but it allows resources. And so resources are these cloud resources. So things like your EC2 instances, things like your EFS mounts and things like that. They allow resources in a private subnet to access the internet. So again, we talked about the Internet Gateway. It kind of sounds like an Internet Gateway. You're like, oh, like we just learned about something that allows you to access the internet. Remember, that was for a public subnet, something in a public subnet, resources that are in a public subnet, and it allowed information to go from the resources to the internet and vice versa. So from the internet down into your resources. But this allows private subnet items to access the internet. And again, think things like updates, like when you saw me run an app update. So think things like YUM updates and connecting to an external database and being able to pull information down using wget. But it only works a single way. So it only works from the internet in. It does not allow, it only allows for the resources to reach out to the internet, but not for the outside internet to reach down into your resources. So that's very important. The internet at large cannot get through your NAT to a private resource, to your private resources, unless you explicitly allow it. So you can allow it, but usually the goal of this is to allow your private resources. So maybe you have some servers that you don't want anyone on the outside to have access to, that, utilize. So they do some background processing and they're really important for your company, but you don't want anyone from the outside to be able to get to them. It's not important. Internal systems consume them, but you want to make sure that they're up to date. You want to make sure that they can get software installed on them. How do you make sure they do that? That is, again, through a NAT gateway, a Network Address Translation Gateway, which again allows resources in a private subnet, not public, private subnet, to access the internet, but not the other way around. So two similar things here, but they serve different purposes. Again, Internet Gateway, it's a two-way connection. It's from your resources out to the internet and from your internet into your resources. And these are things that are in your public subnet, whereas the NAT gateway is a one-way thing where your resources can access the internet, but the outside internet can't access your resources. And this is for things that are in a private subnet. And again, this is by default. You can explicitly allow it, but you probably would not want to. So let's go ahead and run through and set up our first VPC. We're going to run through, I'll copy this for everyone. We're going to run through this WizLabs tutorial. So WizLabs is a pretty cool, site. Basically they have a lot of AWS training material and practice tests and things like that, which is super great. If you're studying for the AWS exams and you want some good practice tests, I would definitely check out WizLabs. If you want to, if you're trying to pass, I think it's valuable. Don't think it hurts. I don't think it's very expensive. I don't think. Maybe their prices went up. Let's see. Let's check really quick. It looks like right now you get a 15% coupon. Excuse me, sorry. Okay, yeah, so your practice tests are only $19.95. You get 19 tests with over 600 questions. Again, to me, that's a small price to pay to get, solid questions to practice with if you're trying to get your exam, if you're trying to pass your exam. So just something cool to check out. But we're going to be using this tutorial. I hope it's up to date. It looks pretty good to me. And I just wanted to, because I wanted to run through a specific tutorial, because I think the first time you're setting up VPCs, it can be very confusing, especially because you're diving into some networking concepts. Like, there's a lot that's packed in here that's not just AWS specific. Again, we're talking about subnets, subnetworks, and we're going to be talking about these different things. And there are some concepts that apply, like security groups that are AWS specific, and these internet gateways and route tables and stuff. So it's good to have something to refer to. I think it just makes it a little bit easier to follow along. And it gives you some extra context around some of the stuff. When I was reading through it before, they don't do the best job at explaining some of these different pieces. If you're in the Google Classroom, there's a Medium article that dives into the pieces of a VPC a little bit more. And I think that's a little bit more valuable. But yeah, I think combining both of them could help. But what are we going to cover here? We're just going to go ahead and do this piece, which is creating a VPC. But we'll have to set up all this stuff. So we're just going to get everything set up. So let's get logged into AWS first, and then we can run through this. So I do, in fact, have my phone today. I didn't forget. And this is actually good, because I think we have some services spun up here still. So it'll be great to show that when we spin these things up, when we create our own VPC and we add some services inside of that VPC, we'll get to see that, like, they'll all show up where we're used to things showing up. It won't look different to us. It won't actually look different to us. We'll be able to see our services and stuff in the same place. But I should be able to quickly display, like, that you don't have access to things from one server to another. And yeah, so like this EC2 instance is in this VPC right here, this VPC ID, which is the default one. Again, Amazon does set up a default VPC for you, a default virtual private cloud for you that kind of has, free access to the internet, or is already set up for access to the internet, which again, most people want. And it's got all your little stuff in here already set up for you, which is nice. So we're going to replicate, and we're going to basically make our own that we can utilize for a lot of things. And so we'll use this as a base for a lot of stuff we go into. I think we go into the infrastructure as code stuff next, I believe, which is great. And so we can start using these VPCs to kind of set some things up as well. So that'd be pretty cool. And also generally, like, I don't know, I haven't had to set up these things by hand in a long time. So these next parts might be kind of fun, like going straight from doing it, by hand to immediately the next week, setting it up via code, which would be nice. I prefer to set these things up via code. I think it's a lot easier to manage. I actually think it's harder mentally for me to set things up manually like this through the console. But again, great practice. Definitely add some context to the stuff that we're doing. So cool. Let's get started, and let's follow along with what they have here. And let's start setting up a virtual private cloud. So in this task, we're going to create a VPC. It's going to let us know to go to the AWS management console. We're already here. It tells you can see here how poor the UI for this is. It says, go ahead and just search it. Don't even look for it in the menu. Go ahead and just search for VPC. And we're already there. It takes you to the VPC dashboard. And then it gives you a little watch out call out here to just let you know that, hey, there is a default VPC here. And again, all this is all networking. Networking can be finicky, but it's already been created and set up. It's basically just letting you know here that that you have one that's available, but like watch out for it, because if you're going to mess with that, you're requested not to delete any of the existing VPCs, subnets, root tables, internet gateways, security groups, or network ACLs. They don't want you to break stuff that's already existing inside of your setup, which is very important because it can be tough to get those things back or reset those things up. So cool. You don't want to mess with any of that. And so I think ours is named. Is it already named? If not, let's give it a name. Default. We'll just put a name in there really quick so that we can quickly identify it. So that's the one that already exists. All right. Close this. Excuse me, sorry. We'll leave this up. Okay, so first thing we're going to do is we're going to create the VPC. So that is very easy. Like creating the VPC itself is a pretty simple process. So we're simply going to click this create VPC button. And so it's going to start to take us through a very similar installer or setup process as like the EC2 instance that we set up, or like the S3 bucket that we set up. It's going to take us through kind of just a walkthrough installer here. So it lets us know what a VPC is. Isolated portion of AWS cloud populated by AWS objects, such as EC2 instances. You must specify an IPv4 address range for your VPC. Specify the IPv4 address range as a classless inter-domain routing block. This is a CIDR block. I think we quickly dove into CIDR blocks. It is a method for classifying and allocating IP addresses. So those numbers that allow you to get to a networked item. So right here, you see 10.0.0/16. So this is a CIDR block. This /16 is a designation. It's a base designation on how many addresses you want to grab. So this actually represents a significant amount of IP addresses. We can go to a CIDR calculator to tell you exactly the range, but this is a notation that you do not need to memorize, but it is something that you need to be familiar with. Definitely Google CIDR blocks, or like see if you can find a little bit of information on CIDR blocks. It can be a little bit difficult to get your head around at first, but it's just a way of specifying a range of IP addresses. You cannot specify an IPv4 CIDR block larger than 16. Okay, so 16, the number is actually, it says larger than 16. You might be thinking, hey, well, if you drop the number down to 8 or something, maybe that's less. It's the opposite. This actually is more than if you went like 32. If we double this, if you went 24 or 32, those designate a smaller range of IP addresses. Cool. So let's give it a name. Let's give it a simple name tag. And again, we'll just call this our stream. We'll simply call this the stream VPC and CIDR block. So let's see if it tells us what to do. This says do my AWS Lab VPC. Again, it's just a name, but I would stick with their CIDR block. So we're going to go ahead and give it the full 10.0.0/16 CIDR block. So this is actually an internal address range. This is a private address range, and we're going to talk about this in a second. Don't want an IPv6 CIDR block. We'll just leave that default for now. Well, let's see what this says. Doesn't even have it here because it probably was not an option when this was written. Tenancy default. So you have default or dedicated. We talked a bit about dedicated versus kind of the default kind of shared tenancy. This just means that if you need your VPC running on dedicated hardware, on hardware that no one else's stuff is running on, you need to pick the dedicated one, and that costs more money. I believe it costs more money. Maybe it's free now. Yeah, cool. So let's go to next. So just that fast, a VPC was created. It didn't take any time. It went ahead and it set up a VPC for us, a VPC that we can use now, no problem. We could right now start creating AWS resources inside of this private cloud. So again, right now, this is its own sectioned off kind of networked private area inside of AWS for our resources. Yeah, that's all. Is a little box for our resources. Again, created via a network. But it does not have all the other all the other things that we talked about tonight, it doesn't have those things available by default. It does have the route table. We talked about a route table. It gets a route table. I'm not sure it has anything in it by default. Routes. Yeah, nothing here. Cool. We're gonna set these things up. But what else do we have in here? So we have that CIDR range that we pasted in. So that's there. It's available. Default VPC. No, it's not the default VPC. And then with this network ACL. So this is network access control lists. I believe these are stateless. But these will allow us to do some set some rules on the types of traffic that can come in and out. Again, similar to your security groups, but these are done on similar to your security groups. I'll leave it there for now. We do also have security groups here as well, so not just these network ACLs, but that is something that you have available to you. Go back to our VPCs. You can see here that I do have 2 separate VPCs. I've got the default one that we have here, and we have the stream VPC one that we set up. Cool. And that's all you kind of need to see here. And let's run through everything else that it tells us to do. So we created it, all done. So now we need to create a public subnet. So in this task, you'll create public subnets to launch your front-end web server onto. So sounds like it's going to be setting up, and maybe we can set up like WordPress or something here, just to see. But it says it's going to have us create public subnets. So what are subnets? Subnets are subnetworks. So they're subnetworks of other main networks. And again, these are each subnet will be in a different availability zone. So we talked about regions versus availability zones, and that a region is the geographical region where data centers kind of physically are located. So again, we have US East, so we have like Northern Virginia and US West, and we have things like Singapore. So those are the regions. Those are the high level geographic places that these things lie. These are the regions that are available inside of AWS right now. And inside of each of these regions, there are these things called availability zones. They are clusters of data centers that are also geographically dispersed within these places, and these subnets will get tied to an availability zone in whichever region you're in. So we're in this US East one, the Northern Virginia one. So now we're gonna create some subnets for each of these things. So let's go back here and let's see if it tells us what to do. So in the navigation pane on the left, we're gonna go ahead and click subnets. We're gonna create a subnet and give it some information. So let's go ahead and do that. So subnets here. And you can see there's already some subnets created here, and it tells you which VPC these subnets are a part of. And again, they're all a part of the default VPC. So go ahead and create 8 subnets here for us. Create a tag. Whoops, why can't I make this large now? It really won't let me, hold on. 1 second, Linux is, it's getting me good. Off, back on. There we go. Give it a name. So what's the name that they gave it? So they gave it, wait, this is public. So we'll just do that. We will say stream public. And we select which VPC this is a subnet for. And so we're, click the drop down here. You don't need to memorize the VPC ID, and go ahead and click stream VPC here. And then you select your availability zone. So again, I have all of these options for it to create my public subnets. And so I'm just gonna click 1A. Well, let's see if that's what they want us to do. So they did 2A here. Let's just select the first one on the list. So yeah, we'll go ahead and just select the first one, which is 1A here for our availability, for our region. So cool. We're setting up the subnet. We told it what VPC this subnet is going to be in. and we told it which availability zone the subnet should be in. And then we can leave this here. And let's see what CIDR blocks they would like us to use. So now what we're going to do is we are going to take, during the VPC creation portion, when we selected the CIDR block range, I think this is like, hold on, let's see. Let's CIDR range chart. Let's do calculator. CIDR 10.0.0.0/16. Calculate. So this is pretty small. So what this does is this basically gives us from the first IP, which is 10.0.0.0, all the way up to 10.0.255.255. So that's basically, as this last octet goes from 0, it gives us 10.0.0.1, 10.0.0.2, 10.0.0.50, 10.0.0.100. It gives us all of the numbers in between this and this. So we get a bunch of stuff here, and it's this many hosts here. Yeah, because there's many hosts. So we have a lot of IP addresses allocated to us. How can we get so many IP addresses allocated to us? Again, these are private addresses. So each of your VPCs can use these same private IPs. These are not public facing IPs. There's not an issue with them having overlap between different spaces. So we have a lot of IPs available to us. What we're doing now with the subnet is basically saying the VPC has this many IP addresses. You have this many IP addresses available to you. Now we need to select our own kind of range of addresses that we want this subnet to basically have assigned to it. And so what they have here is they want us to do 10.0.1.0/24. So let's put that into our CIDR range calculator. We'll calculate. And so this goes from 10.0.1.0 all the way up to 10.0.1.255. So this is only 256 addresses. And again, that is from 0 to 255 here. So we'll have in this one subnet, we will have 256 addresses available to us. Why do you use AWS if it costs 4 to 5 times more than a dedicated server co-location? Because that is one flexibility. So if you have dedicated servers or you have things that are co-located, you're either over provisioned at pretty much all times, or you are under provisioned at almost all times, and that can be very costly. So flexibility is number one. 2, that is only true once you get to a certain scale. Dedicated servers and co-location is not always cheaper. AWS does not always cost more, but there is a myth out there that AWS is cheaper than everything else. That is not true. There are many situations where going dedicated or colo can be that. But again, flexibility is the reason why you would do that. The services and the speed at which you can move is the biggest factor. Being bound by the servers that you already own and the amount of time it takes to extend that dedicated infrastructure it can cost you a lot. Being able to be agile and move quickly, create new features using the tools that you have available to you, instant provisioning of resources is a big call of the cloud, is a big deal, and that's what you'll learn in the infrastructure as code piece. Why that is. So yeah, I mean, again, it's not, AWS is in the cloud is not the answer. It is an answer. Yeah, I mean, we can definitely hit some real, maybe when we're done with the AWS portion, we're getting into the other stuff. We can really dive into solutioning out infrastructure on both dedicated or co-located hardware versus the cloud. And again, there is, just like with anything else, there's always trade-offs. But the cloud definitely, to me, has huge advantages over. I actually used to work at at web hosting companies where that's what people would order, is just dedicated hardware or co-locate servers with us. And I can tell you that being able to move during that process is extremely slow. Oh, be careful leaking your IP. Yeah. I generally am careful about it, but the way that I have my things set up right now, not too worried about it. But I will be cognizant of it to try not to leak my IP. But if I do, I have ways around it. But cool. So let's go back to creating this VPC here. So we're gonna just take these 256 addresses for this here, and let's see. Did we paste it in yet? We did not paste it in. Paste that in, and we'll click create. So very quickly, this subnet was created. Again, your IP was on screen. Not a big deal. Not a big deal from mostly because of where I am. Replay portion for that. That's fine. I'm not at home. And there are some networking that's set up here in regards to exactly that, but that's fair. I'll be cognizant of that. And again, was it Freedomadao? This piece of it, if you were doing something like this on your own dedicated server, the application and the assigning of these subnets, this networking setup, the thing that took me 2 seconds, it takes far long. We're talking about a 100x amount of time. So yeah, just benefits, trade-offs, definitely trade-offs. All right, cool. So we have this here. We have our public subnet set up here. And again, these are all the ones that are set up for our default VPC. So let's check this out. Yes, create. So we created that. And we have our public subnet. So are we all set to launch our web server? Well, not yet. Why not? We set up a public subnet, but it is not a public subnet. Why is it not a public subnet? It's because, well, they're gonna explain it here. Do you know why it is not a public subnet? By definition, a public subnet must have an internet gateway. So we talked about that. A public subnet needs to have a route to the internet for it to be public, and an internet gateway needs to do that. Next task, you'll add an internet gateway so the instances in your public subnet can access the internet. So we've created a subnet. We've taken some of these addresses, some of these private addresses, and we've put the tag on it that is public, but it's not actually public until we make it public. So we're gonna go do that with an internet gateway. And again, remember, an internet gateway allows you to, is gonna allow this information to travel in 2 ways, both out of the VPC to the internet and from the internet into the VPC, as opposed to a NAT gateway, which is for private subnet items, which only allows for, by default only allows for external transfer. So from a subnet out to the internet. You don't worry about me. I have way too much stuff. That's positive mess. One's IP who is actually, yeah, I'm no, 100%. I'm not worried. I'm definitely not worried. Cool. So we have that here. So we need to create this internet gateway. So let's let them take us through creating the internet gateway. So we'll click in and we'll just, same navigation pane. You'll start to get the feel of how to use, AWS and kind of how things are set up. Again, it's not consistent through every service, which is pretty annoying. But yeah, for the most part, you'll have some options over here or somewhere around here, and just search for what you need, and you can go ahead and click on this. So now we need an internet gateway. When we click into it, we already see that we have one internet gateway set up. Again, that's for our default VPC that we already have set up. It lets us know that it's attached here. If we wanted, an interesting thing about these internet gateways is I could detach it and attach it to another one, but I'm not going to do that. So let's go back to their stuff here. We're going to go ahead and create one really quick. Create one. And again, we'll just call it stream internet gateway and click create. Super fast. We've now created a new resource. I'm gonna close. Now we have this Stream Internet Gateway here. And again, it says detached. Remember, a lot of the stuff in the cloud, a lot of the stuff that we're gonna be creating is gonna be us grabbing, creating resources and basically kind of putting puzzle pieces together, creating things that do certain things and using those and combining those things to build out the solutions that we need. So that is what the Internet Gateway does here. We're gonna be able to attach this to our VPC and do that. So, let's follow them along again. Click to attach to VPC. So we're going to go ahead and attach it to our VPC. So I guess you could go to actions and attach to VPC, or you could right click here and click attach to VPC. We'll select our VPC. It's only going to show you the available VPCs that this is not attached to, because you can only have one Internet Gateway attached, I believe, to to each one. I'm pretty sure. Cool, and it looks like it's gonna have some stuff here that's gonna show you the CLI command to do this, but we'll just go ahead and attach it. And just like that, immediately the state is now attached, and it is attached to our VPC that we already created. So great, really simple so far. We're just kind of clicking through. We may not know exactly what we're doing, but the acts of doing it are pretty simple. Haven't had to do anything tough yet. But yeah, so far, I hope everyone's following along. So, now, even though you created an Internet Gateway and attached it to the VPC, you still have to tell the instances with your public subnet how to get to the internet. So it's a gateway. We got to tell it. We have to set up the tables that kind of tell the route that these requests need to take to be able to, connect to the internet. So in the next task, we're going to add a route to your main VPC route table to tell the traffic in your public subnet how to get to the internet. So we're going to set up this route table, and we're going to tell it how to use the Internet Gateway to get out to the internet and for information to come back in. So let's set up some route tables and set up the routes. In the navigation pane on the left, go ahead and click on route tables. Open all the ports and use UFW. I'm cool with that. I'm not afraid. I am not afraid to do that. You saw it last time. I'll open up everything. I'm not scared. I'll just kill it afterwards, but I don't recommend it, but I'm not afraid to do it. So what are we doing? I already forgot. Route tables. We're gonna create our route table here. We can see here that we already have a default one that gets set up. Whoops. Scroll to my thumb scroll wheel doesn't work in Linux. That's weird. All right, so we have one here. It's our main route table for this. Already set up here. So we're gonna go ahead and we're gonna modify that to work here. Let's see. What's it about to do? Oh, back to here. Okay. So we created it. There's currently a default main route. So we saw that one. So we're gonna go click it. And then it says, notice that there is one route in your route table. So we already saw that with the first one that we looked at, but let's click into it and let's expand this and look at the routes that we have here. All routes 10.0.0/16. What does that look like? Again, that looks like the same CIDR block that we created with our VPC. So it looks like that is in there. Status active, propagated node, target local. Let's talk about those things. Let's see if they talk about it first, and if not, we'll talk about it. This route allows traffic from 10.0.0/16. So that's any of those 65,000 addresses or however many it was. It allows anything from that network to pass to other nodes within the network. So it'll allow this route allows anything in that subnet to kind of connect to anything in that subnet, but it does not allow traffic to go outside the network. So it allows traffic to basically travel within the network. So all those addresses can kind of go around and connect to things that are in that same network. No, I'll do that, to be honest. I just had it the first time. Yeah, sometimes you need to do it for troubleshooting, open up ports just to make sure things aren't networking issues, or if they are, where they are, if it's, the application layer or wherever. So yeah. it can be pretty interesting. What do you think about Ansible? I like Ansible. We're going to be using Ansible during our infrastructure as code piece. If you must do runtime configuration of a server, or of a resource, I think Ansible is the best option in the configuration management stack. But I have become a fan of not doing runtime configuration at all, and do basically building golden images or building images, and kind of making sure my dependencies are there rather than doing any type of runtime configuration. So I don't know, if you have to use one for your setup, then I do think Ansible is the best option of them all, but I would prefer not to use a configuration management tool at all, and not do it at runtime, do it at build time. So yeah, we'll talk about that more as well. Cool. So click the routes tab. We see this here. Click the subnet association tab. So what is it going to have us do here? So it's going to have us, every single time that we create a new subnet, it's going to be associated by default to our main route table. So the main route table already existed. Every time we create a new subnet, it says it's going to be associated by default to that main route table. You can browse this same tab when we create another subnet, the private subnet, later on during this lab. Now, for that reason, we don't want our main route table to have a way out to the internet, because every time you create a subnet, it should become internet accessible. So this little blurb here, this paragraph here, is basically saying, hey, we don't want to associate, we don't, in our main route, our main table route, we do not want to give that access to the internet, because then every time a new subnet is created, it will automatically be internet accessible, and that is not what you always want. So let's create a brand new route table. So instead of using the default one, instead of modifying the default main route table, we're going to create a brand new route table. All right, so let's go back in and let's create a brand new route table. What do they call it? They're calling it their public route table, so we'll call it a public route table. So we'll call it stream. I don't think you have spaces. Route table. And we're gonna connect it to the VPC that we want, which again is the stream VPC. And create it super fast. So now we have a route table. So what have we done so far? We've created the VPC. And in that VPC, we've assigned, a CIDR block, given it an internal address range, that 10.0.0.0/16 range. So we created the VPC called Stream VPC. We've created an internet gateway for it as well. We've created a public subnet. We've created the subnet, which we've called public. Now we're doing the things that are necessary to make sure that it actually is public, that it has access to the outside internet, and that internet has access internally. So we are creating the route table for that now. So we did that. That's here. Let's see what other setup we need to do here. Yes, create. Did all that. Great, now you're ready to create a route to the internet. So we created the route table that it's going to use, but now we need to actually set up the route, the actual networking route that this can take to get out to the internet. So select the route table that we just created, click on the routes tab, add another route, click the destination field and enter 0.0.0.0/0. So this piece of it, 0.0.0.0/0, this is the CIDR range for every IP address. So this is everything. This will basically allow anything, any kind of connection. So let's go ahead and let's do that. So route, this is the one that we just created, I believe, because the only one with the name. Edit routes, add route, and we're gonna give it this CIDR block, which was the CIDR block that we created for this was, it wants it to do for everything. That's interesting. Destination. Oh, that's a 0. I mean the destination. Sorry. 0.0.0/. Oh, it's right here. And target, what did it have on here? Did it have internet gateway? Target. Yep, the internet gateway that we created is going to be the target. So our internet gateway, yeah, it's going to have access for all these things. Is it going to let us pick? There we go. So we added in our internet gateway here, and click save. So we're done here. And if it goes back into it, we should see here, now we have a destination for everything, like a local destination for everything. And then we have a target through our internet gateway for any address here. So that's what that 0.0.0.0/0 thing is. You'll see this paradigm as well when we do things with security groups. So this is something that, again, that's why CIDR blocks are good to at least get a high level understanding of. So you notice when you see it, you'll still, like me, you'll probably have to Google it to find out exactly what to do after that, or what the actual designation you need is. But yeah, but there we go. What's up, Fitzroy the Hacker? Fitzroy the Hacker. Got it. What's up, Fitz? Welcome to the channel. Thank you for the sub. Appreciate it. Check out Discord. Do bang Discord. So information about the Google Classroom is in there if you need it. But 3-month streak, so you probably already got that. Probably renewal, so thank you. Would you model these subnets as trees or graphs, then trees? I don't even know what you're asking me here. Again, networking, I'm a DevOps guy. Networking is my weakest, is by far the weakest section of my DevOps ninja chops, for sure. I have no idea what that question even means at all. So maybe if you want to ask it a different way, maybe I do understand what it means, and I'm just not sure how to answer it when phrased that way. Yes, ask it again, and maybe I'll dive into what I think you're asking in a second. I might have I have an answer for you. I don't know if it's necessarily a good answer, but I'm gonna keep going, but see if you can ask that a different way. If there's not a different way, then I'll try to answer it in the way that I know. Let's see here. So we've done that now. Security group, associates public subnet, public. So now we've created this so it can have access. This subnet can now gain access to the internet. It is now essentially a public subnet now. So it's now letting us know that security group acts as a virtual firewall for your instance to control inbound and outbound traffic. We've learned about security groups when we went over EC2 instances. So again, this is this virtual firewall that we can use to control traffic. But it does it on the instance level and not the subnet level. So if you don't specify a particular security group at launch time, the instance is automatically assigned to the default security group for your VPC. So we can look at the default security group and see what that looks like. Security groups here. Default VPC. I wonder why there are two. Inbound row count, which takes everything from this VPC, everything outbound. Not sure what the difference between these two are. Same rules. Why are there two different? Not sure why there are two different ones here. This is probably from the one that we just created. Or got set when we were doing some of the other stuff last time. All right, so let's check what they want us to do now. Create a security group for your public subnet. So again, this is that virtual firewall. This is that virtual firewall that will allow you again to control the connections at an instance level, again, at the VPC level, rather than through networking, rather than through subnetting. And again, this may be a better option for you. This could be a better option for a number of reasons. It can also be a worse option for a number of reasons. I found that you should control as much of your security via the network as possible. Yeah, I think it's kind of your base layer. Anything that you're controlling with your Security groups here has already kind of gotten past that portion, has already entered into your VPC, your virtual private cloud. It's starting to hit your resources, and AWS then takes care of it. Yeah, so I think as a general rule, if you can, block access to unnecessary things, doing it on the networking VPC subnet level is probably a little bit better. But again, this is just extra little information here. All right, so we're gonna create the security group the same way we did it like everything else. So we've created internet gateway, we've created subnets, we've created, what else did we create? Internet gateway, a subnet. We created one more thing, internet gateway, the VPC, internet gateway. We created a subnet and whatever. That's what we've done so far. We're gonna create a security group right now. So we're in here, let's go ahead and create a security group. Security group name, we'll call it stream SG. What time is it? 9:01. Cool, we're making good time. And I'm glad that I just saw that my laptop's not plugged in. I'll make sure I get it plugged in before it dies. So stream SG, test, stream example SG or VPC creation demo. All right, got a little bit of information there. I'm trying to visualize what these components might look like. So if you're trying to visualize what these components, we'll do a draw.io maybe as soon as this is done. Yeah, maybe we'll do a draw.io to kind of show what these might look like. That's a good question. I like that, and I actually like doing things more visually. And I was planning on getting an iPad for that, so I could like draw some stuff out. We'll use draw.io for now since I don't have an iPad. So we'll actually, let me pull it up now so I don't forget about it. So it's just sitting over here, and we can kind of try to visualize some of these things. Create new blank diagram. We'll just set that right to there. All right. So in here, they're going to basically have us select create security group. So we created the security group, or we're going to create one. Click the inbound rule. So we're going to create an inbound rule. And then, so again, this is something that you've seen. So like, we're going to set up a custom TCP rule, for port 80. Think back. What should we be thinking when we hear port 80? In the protocols right here, HTTP, this is the default port for the web. So this is gonna basically, it looks like we're gonna be allowing web traffic over port 80. And then we're gonna allow it from enter the IP address of your laptop network. It looks like they're only allowing it from their laptop network. We're not gonna do that. We're gonna just add it from everywhere for now. And click save. Cool, so let's do that. Let's go ahead and set up a security group. So we're gonna assign it to the stream VPC security, VPC. Stream VPC. And then we're gonna, now that we have this, we're gonna go ahead and edit the rules, edit the inbound rules. We're gonna add a rule for custom TCP rule. Port range is just port 80. And we're gonna allow it for anything right now. That's fine for this subnet. All right. And so generally you're not gonna do exactly that. You're not gonna allow everyone access, but not a big deal right now. Again, this is just to, again, high level go over all the pieces that are a part of a VPC and how you kind of get through them. So we now have a security group, and now you've been awesome, Guru. Did you realize what you've created so far? And actually, this might help a bit for the visualization. All right, this actually, wow, they have so much just stuff here. They're trying to sell me everything. And so you can see here how this is wrapped in the region. So again, region, high level, sections of the country. This says US West 2. Ours is wrapped in the US East 1 region, which is the Northern Virginia region. So over here on the East Coast. And then inside of that this is where your own carved out cloud is. So it exists inside of this region. The cloud gets put here inside with a public subnet range that looks like this. And so that is what essentially it uses networking to carve out something that is only accessible by you in your account, whenever you give access to it. So what we're now doing is we've created all these pieces. We've created this public root table. This default root table is already here. And then we've got these network ACLs, which we've basically just, we've kind of set up, which are going to go to the security group. So information is going to go like this. It's going to come in through whatever network is set up to go through the region, through our VPC, CIDR blocks or whatever. It's going to come in. It's going to come in here. It's going to come into the internet gateway. And then basically it's going to pick a route based on the things that you set up. So if it's hitting a public subnet, the subnet that you created, if it hits that, it can take this public route. It can go through your network stuff that will allow it, and then it'll hit that security group that we were just talking about, and it will allow, again, whatever you allow. So we allow port 80. So if it is over port 80, if it's making an HTTP request to whatever services are inside of here. So right now, that request wouldn't do anything. Allowing port 80, but having nothing that can respond to port 80 inside the subnet means nothing will happen. But if we do put something in here that can respond to it, that information will be able to be retrieved, and vice versa. Whatever resource that was could go back through the same route to be able to get information from the outside internet. And again, we'll still make that draw.io for the subnets. But yeah. When do we create a network ACL? That's not on the quiz. Yes, this is created by default. So an ACL is an access control list. And so these are created by default. We are not going to create a separate network ACL for our subnets and consider using the default network ACL instead. So we can look at our network ACL. You can see here it's in the security piece. And basically what we have here is, we have this. So we have our subnets that are associated with it, the subnet that we created. And again, in here, we have some other information. We're basically allowing all inbound traffic by default. First we're allowing, then we're denying. So these number priorities, actually, I think we're denying first, then we're allowing. I can't remember which one. I can't remember if star precedes, but these number rules are the ordering and preference. And so you can use those weights to determine what you want to happen. So you can have both explicit allow and explicit deny rules, and they'll take certain actions based on their placement here. And so these are set up by default to kind of let everything go through. Oh, sorry about that. Cool. So our network ACLs are set up by default. So you'll get that by default. Now it's just saying launch a web server in your public subnet. So we can go through and real quick, we just launch a web server. And maybe I'll launch one in the public subnet, and maybe I'll create a private subnet as well and show you that if we launch something in the private subnet without, access to the internet gateway, like we wouldn't be able to serve data through it publicly. We could get through it internally, like from another service that was in the internal network, but we couldn't get through it publicly. So we'll go ahead and we'll spin up a quick EC2 instance now that we have our own VPC set up, and make sure everything's working correctly. So we have 2 VPCs here, which is great. EC2, let's go ahead and let's spin up a new one. Launch an instance. Again, stick with Ubuntu just because that's what we've been using. Select it, we'll keep it on the micro, free tier eligible. And now here's where we can select which VPC is going to be in. So on this network screen, we just choose the VPC that we just created, which is Stream VPC. And then we tell it to use that public subnet. If we had other subnets, it would give us those options. But again, we only are going to use this. Take a look at this though. says 251 IP addresses available. When we did the CIDR calculation before, it let us know there were 256 that were available. This is because this is a bigger thing, and I think I'm not sure we'll touch on this. This is something that is important inside of AWS, but AWS reserves a couple of IP addresses for certain things, to do different things, to do some of their management. But yeah, it reserves some of them. So you only get for each of those like slash was it 24 CIDR blocks, you only get 251. You're going to have a few that are removed. You're going to have 5 that are removed, basically. So just something that's good to know. It is on the exams, and it'll ask you what those things are for. I'm not going to go over what those things are for right now because I think that'll just be confusing. But yes, there are some subnets that they keep reserved for themselves that AWS kind of needs to run. So auto assign public IP. Yeah, I'm going to enable this because we want this to be, yes, we're going to auto assign this public IP. What's up, Viable Clan member? Welcome to the channel tonight. How you doing tonight, man? Let's see, placement group. So actually, we don't need to talk about any of that. We are past the EC2 portion. We're just going to make this server really quick. Instead of we'll set up a quick web server on it really quick, just so we know what's happening. Value is going to be stream VPC example. I mean, AWS. We're on the core stuff right now. Like VPCs are very important, but something that I don't consider to be very fun. But yeah, I mean, I think it's because I don't consider any networking heavy thing that fun. Just because, again, it's not my forte. But we're getting through it. We're definitely getting through it. So like I love Tuesday, serverless stuff. I love serverless stuff. So I'm super excited about that. This is much more boring to me than serverless. So we're gonna create a new. Well, we'll just leave it here by default. Launch it with the cloud key that we have so we can log into it. All right, so it's going to spin this up. It's going to spin this instance up in the VPC that we created. We can confirm that right here. Again, stream VPC. This is the ID for the VPC that we care about, that we just created. So that is great. Now, if we set things up properly, well, okay, actually, it's probably not going to let us connect for security group reasons, but we can go back and we can modify that in a second. But if we set things up properly, we should be able to now connect. Let me get this here. Takes a little bit to set that up. All right, so let's see if we can get into it, which we should not be able to, but this will be the fun of it. All right, so I'll just might as well go into the folder that has my AWS keys, and we'll set up our SSH command. We use this cloud.pim. We're using Ubuntu. All right, so we're trying to log into the server, and we cannot log into the server, where we know that before we were able to just spin up a server and we were able to log right into it, no problems, very, very, very easily. But we do not have that chance right now. It's not working out for us. Generally, when you see a command like this, when you are connecting with something remotely, when you see it kind of just hang like this is generally a networking problem. It's generally because, it's generally because you can't connect for some reason. So what we're going to do now is we are going to, this actually may not work by default either, but I'm going to check. I'm going to go ahead and I'm going to, one thing that we did not do is back to the VPC section, is we allowed the connections over port 80 through our VPC to our public subnet, but we will go ahead and we will add that to our, you got it, show enough, security group, port 22 for our VPC here. So where do we have this at? See, back to VPCs, back to security groups. The security group that we created is right here, the Stream SG security group, inbound rules. So let's set one up for the port that matters. So what port is that? This port is custom TCP rule. This port is port 22. We know that SSH is port 22, and we'll set up for anybody can log in because we have those sweet SSH keys, and none of you have my SSH key, so you can't get in. Unless you shouldn't be able to get in. If you get in, that's fine. I'll just delete the server. And let's see what happens now when we try to log in. And we still get nothing. Actually, let me check one more thing really quick. I'll leave that running for a second. Let that run for a second. And we did our inbound rules. Outbound should be open. Just making sure everything is good to go. Port 22, allow anyone to connect over SSH. And then just to make sure our EC2 instance should have this by default. Example. I wonder why this didn't give it a public DNS name. That's fine. Where was I gonna go to? Where are the security groups? All right, so this is open as well. So is it gonna let me connect? Probably not. And so again, I think this has to do, right now, we can check this in a second. This has to do with a few things. Well, not a few things. One main thing is the way that it's assigning this is the address to this. I actually want to see what's gonna happen if I actually kill this server, if I actually terminate it. I just want to check something out real quick. With this, I think we have one more networking problem that we have to work out. Right back here to dashboard, instances, VPC example, terminate. I'm gonna launch one more really quick. Details, stream VPC, public A, auto assign, use subnet setting disable. I'll leave one with just the automatic settings enabled. Name, we'll call this, I forgot what we called the other one. We'll call it VPC example. We'll call this one the VPC example 2. Security group, port 22 is open. We'll go ahead and add 80 here as well. Same key pair. All right, let's head on back over to EC2 here. Whoa, oh. Wow, what is this? When did this happen? Terminated. Did I click terminated and not restart? Oh, maybe I did. Interesting. I might make one more like that. So this one's not gonna work because it's not gonna give us an external address. So I wanted to see what the default, I couldn't remember going through the default process, what we made our VPC default subnet settings. So you can see here that right now we have a private DNS address, an internal address, and private IP address. This is not accessible from the outside. So what's up, Zalquernane26? Welcome, thank you for the follow, welcome to the channel. But it did not assign us any public information, which is great. I'm gonna leave that running because we're gonna access that in a second too. I terminated the other one when I wanted to just reboot it. Not a big deal. Not a big deal at all. See here, we can just spin stuff up at will though. Pretty easy to do. Enable auto assign public IP. But again, I do think we need to make one more change. I just want to have 2 up, one with no access externally, and one with a interesting, and one with external access. We'll make this 2 and 3. Make this one also have HTTP. All right, here we go. Launch this baby as well. Launch. knowledge. I can't wait till we get to Terraform so you can see how easy it is to spin up a server like this without having to click through like this. You can see here, this gets assigned. This is interesting. There's definitely something we have to change. I'm gonna look through in a second, but I am gonna check and see if I can connect to this now. VPC security group, VPC internet gateways. VPC, and this might be a network ACL portion. See, route table. Oh, I thought, oh, did we edit the wrong? Edit route table association. Got it. This is why. All right, so basically what happened here is the route tables that we set up. So again, a route table gets set up by default. And they had us create, basically they were saying, hey, if we allow public access through the main route table, then any subnet we create is going to go ahead and have public access, and that's not something that we want to do. So we created a second we created a second route table which had the public access, where the main one remained not having the public access. The problem is now you need to associate the subnet that you're on. You need to associate this subnet with the proper route table. So when I took a look at it, it was still associated with the original route table that we had created, and not the original one that was created. We did not assign it associated with the one that we created. So I went ahead and created that. And you can see here, it actually does have the rules here that go through our internet gateway. And now we're able to connect. So that is the main reason. I knew we had one more. I knew there was a networking problem that still existed, but this is still good because we can see here that we have a EC2 instance that is not publicly accessible, even though it is in our public subnet. It's not publicly accessible. So I wanted to just show that. But so real quick, we can do, we can go ahead and update, and then we can install Nginx really quick, just to show that port 80 is open and that we can create a web server that is only, that exists within our subnet, but has external properties. One, you can see here that I can get data from the outside internet. If I create one in a subnet that does not have this external access, like these are public, if I create one and don't set up a NAT gateway, I will not be able to get these updates that I'm doing now, and I won't be able to do anything like this. That is not a package, but this is, and I wouldn't be able to install this either if I was in a public subnet without this. All right, so we did that, and it should be running. So we paste in the IP address and go to it, and you can see that we have our Nginx page. It is resolving over port 80. It is responding over port 80. So a lot of work there. A whole lot of work to set up a VPC that did essentially what our default one did. We basically created a clone of basically the default VPC, but we went through and we did it manually. That's valuable. You will have to worry about VPC creation and managing sectioned off pieces of your network via VPCs. Again, so the way that we actually use VPCs on our projects, and again, you can use them in a bunch of different ways, is each of our developers has their own production-like development environment. And so each of them has their own VPC, which has the things that they need. We use ECS to manage our containers. We use RDS, so a database. We use a bunch of different stuff in there. And so each individual developer's VPC is able to be to manage resources that exist inside it, which is really nice for isolation. It's really nice. It makes it easy to create infrastructure as code that can call different resources and things because they're not using publicly available ones that only specify things that exist inside of them, which is really nice. We also have them commonly what you'll do is, because you don't want to have direct access to these things, we actually have no direct access into each of these things. We actually have basically just like this hub and spoke thing here. We have a VPC, and this is a common paradigm. You have a VPC here that you use as kind of a shared VPC, as kind of a jump VPC that you can go through to be able to access these other things. And so you have something kind of in the middle that'll allow you to do some extra stuff, but everything inside of each of these only has access to the things inside of each of these, which makes that isolation makes things really, really nice. But there are a number of reasons why there's like 45,000 different ways you could use VPCs and isolating different resources and different private clouds to achieve the thing that you want to achieve. I've seen people use it instead of creating separate AWS accounts. I've seen people use VPCs, separate VPCs to kind of emulate that as well. All that, it's all very interesting. So that is VPCs. That's a lot about VPCs, but that is VPCs. We're going to run through everything else pretty fast, but I think VPC is the most important thing to kind of have gotten your hands onto tonight. And I highly recommend you go through and do this yourself, read through, figure out what's going on. And again, if you're in the Google Classroom, I posted another Medium article about VPC creation specifically that I think does a better job of explaining a little more of the pieces that VPCs have to offer. So cool. Any questions right now about that? Any questions about that? And so we'll draw a little diagram here. First off, whoa, that did not work how I wanted. So we'll create this square, which is our virtual private cloud. So the whole thing here is the entire cloud, everything around this is the entire region, entire cloud. Let's see if I can our VPC. How do I move just this? I want to give this a label, but I can't give this a label. All right, so maybe for the questions that you have, Pylang, maybe this is a better diagram for it. So this right here is actually 0.0.16. So maybe this entire thing is the pool of IP address ranges that we originally requested or allocated to the VPC originally. So we have that 10.0.0.16 thing. Again, that's something like 65,000 IP addresses or whatever. So inside of here, I take this, you get a subnet. And so we created a subnet here. And in this subnet, let's say we allocated this, again, we took, what did I put in? Oh yeah, another 0. Yeah, I was clicking pretty fast. Z, that is exactly what I mean. There's another, wow. 10.0.0.0. It's really small on this screen. Can't see it. It looks right for now. I'll fix it afterwards. If not, 0.0.0.16. You have a subnet here that you can assign whatever number of addresses you want here as well. So what we did is we did 0.1.0/24, I believe. And so that gave us 256 addresses that exist within the singular subnet now. So I can assign any of these things to resources that exist within inside of the subnet. So maybe how can I duplicate one? That's not what I have there. I don't have 10.0.1.0/24. I think that's what I have. Duplicate. That looks right. Yeah, let me make it a little larger. That's a little bit better. But now everything on the side is too big. But that's fine. So a little bit bigger there. So you would, let's say we have 3 subnets here that we assign to these things. So now we're out 256, 256, 256. So underneath here, you basically have 256 addresses. Now you have 10.0. Oh yeah, okay, gotcha. It's so hard to like, why is draw so difficult to type in? Yeah, no, it would definitely be confusing. No, thank you. I 100%, super confusing. Actually this wouldn't be the subnet. The subnet would be, we couldn't take this 3 times. It would need to be like this and .3. Yeah, so we've carved out these subnets, and again, you can create, you can allocate what you need to a subnet on each availability zone, public and private. And so again, in here is now a pool of 256 addresses that you can use to assign to anything. So your question was, these subnets as trees or graphs than trees? I still don't understand that, but maybe I can just Google that. Maybe the subnetting trees, maybe tree view. That didn't help me at all. I thought I would be able to get to it, but again, you're not really assigning. Amazon after that will auto assign if you've created this pool. Amazon will auto assign things to that pool if you want. Oh, I'm thinking data structures. Gotcha. Okay, I gotcha. But now that I'm already down this path, I'll continue. You can explicitly assign resources, these certain IP addresses in these pools. And again, I would have probably a public and a private set of 3 or 4, however many availability zones I have available to me, as long as I have open resources available to us. But yes, this is just kind of how it works. It's kind of pooling what you have in here. All these addresses that you just grabbed. And again, this is not these are private, so each of your VPCs can have them. Let me plug in my laptop really quick before it dies. Give me 1 second. Display capture. Where is my camera? There we go. 1 sec. Next time I'll make sure to do this. I only cut off my camera because I gotta climb under the desk, and I don't want to look extra stupid climbing under my desk. All right, we've got power. We are all good. Cut this back on. All right, so there we go. That's a VPC. VPCs are exciting, and by exciting, I said that to make it more exciting than I really believed it was. But yeah, VPCs are very important. They are important. You should dive into them. You should definitely dive into them. They're very important. So let's hop back into this and let's quickly run through the rest of the stuff that we have. So the whole section is about both networking and content delivery. The VPCs are obviously networking heavy. Let's talk about content delivery. So this is actually really cool. And I'm going to show you some of this as well. CDNs. CDNs are a commonly used method of delivering content nowadays with the way that the internet works. What are they? Many thanks to the visuals. Absolutely. I'm a visual person. That's why I like all the GIFs. I'm glad you're enjoying them for sure. So content delivery networks. You've used these a million times, not knowing you have. If you've hit my site at all, I use a CDN here, but they're great things. The content delivery networks, whenever you see CDN, think content delivery network. Amazon's implementation of a CDN is CloudFront. So what does a CDN do? It's a geographically distributed group of servers which work together to provide fast delivery of internet content. So geographically distributed. Again, look at the picture. They are a network of servers that exists different places around the world. These places are actually called edge locations. And what these do is these basically allow you to deliver content more quickly to people who are closest to them geographically. Well, it does in two ways, but that's the first piece of it, is that it allows you to take the content from your site. And if you're using a CDN, when someone over in Africa requests information from my website, if I'm using a CDN, it will grab it from the closest edge location rather than making a trip, halfway around the world and then back. It'll grab it from here or grab it from here or grab it from here to get that information. What makes CDNs cool is it caches the first request from the origin, and it serves cache data until the TTL has expired. So what does that mean? CDNs are great because of this is one of the biggest reasons CDNs are great. It caches the first request from the origin. What is the origin? The origin, maybe I should say first request to the origin and not from the origin, but the origin is your server. So let's say you were, the server that we just set up, let's say it was, displaying a website, that server would be the origin of my CDN. And so if someone from Africa made a request to my server, basically what would happen is it would still hit this edge location first. That edge location would say, hey, I don't have any cache data for this site. I don't have any saved data for this site. So I'm going to go to the source of truth. The origin is the source of truth. I'm going to go straight to the server that is set up that I know I'm supposed to be getting this information from. And so the request will go all the way across here. It'll grab the data and then it'll come back. And then when it comes back through this edge location to give to the user, it will save that request. It'll save that data. Why does it save that data? It saves it so that when someone else over here makes that same request, it does not have to make this round trip thing here. It says, hey, I know what that is. I've got that data cache here. I can just give you this data. So what this allows you to do is this allows you to reduce the load of your main server. So instead of everyone making requests to the server that you have over here, all the people from here reaching out to the server that you have, everyone from over here, all at the same time, it allows you to distribute the data around the world, basically. And it allows that network of servers to easily give your data to people who need it, which is really great. Let me just make sure I'm not getting ahead of myself. Okay. So it caches the first request from the origin, and then it serves cache data until a TTL has expired. So TTL is time to live. So this is basically the amount of time that information should be. You can set an amount of time, a minimum and a maximum amount of time that data can be cached on these edge locations. And it'll serve that data until it expires. Once that cache does expire, as soon as that cache expires, whenever the next request comes in, it'll do the same process. It'll say, hey, I don't have any of this data. Let me go ahead and let me get the most updated data, and I'll go ahead and I'll cache that. So that's kind of how that works. So because of that, so any questions about that piece first? Again, CloudFront is a geographically distributed network of servers. These geographic locations are called edge locations, and they basically people who are geographically closest to them, that is where their request for your information will come from, and they'll basically check if they have cache information for the request that was made. If they do have cache data, if they've already made that request before and they've saved the data, they will deliver that data to the user. If not, they will go to the origin, to the source of truth, to your server to grab the most up-to-date data and deliver it to the user. But they will also, again, save that data for however long you tell it to do. And that is called the TTL, for how long you want that data to live. That's the first piece of a CDN. And some of the CDNs you might be familiar with, we're talking about CloudFront, but maybe you've heard of like Cloudflare. They're pretty big. So Cloudflare is a CDN, and some larger ones that are like for larger organizations or some stuff like Akamai. But yeah, there are people like this, and you can see they use words like secure at the edge. We're talking about edge locations and things like that. So, what's up, Dirk Cash? Good name for exactly what we're talking about. I like it. Welcome. I love it, love it, love it. So let's keep going. Keep presenting. All right. So CloudFront actually sits in front of all of your services. Sits in front of all your cloud resources. So CloudFront is actually the first place that it hits. Once you enable it, it's the first place that it hits. So we're gonna talk about DNS in a second. You've learned a little bit about DNS, but your DNS address, instead of going to your server for your website, the DNS address will actually be CloudFront. It'll actually be an address for CloudFront. And again, it sits in front of your resources. It can substantially reduce the load on Origin's resources. So on the server that you have that is giving out data that where you have your application or your site stored, you can dramatically reduce the load on it. How can you dramatically reduce the load? Remember, scroll back down, in the image before this, what's happening here? Image before this, people are actually getting data from these servers that are closest to them rather than your server. So again, the load is taken on by these edge location servers rather than your server. So you can have a much smaller, set of infrastructure and still serve millions of people rather than beefing up your infrastructure and serving everyone from there. So it can save you money. It can save you money there. You can manually clear the cache if you can't wait for the TTL to expire. So there are times when maybe you need to put out an update, and you don't know how long it's going to take for the time to live to expire. So you can manually clear the cache or invalidate the cache to get people to see your latest stuff. So you can invalidate different paths. So maybe there's one file I only care about. Maybe there's two files. Maybe I want everything that the server, everything that my website has, to now start fresh. I can basically send in an invalidation and clear out all that information. And then when people request the information, initially I'll get a good flow of requests to my actual origin server because none of the edge locations have any data for me. But then again, it'll cache that data pretty quickly, and then it'll be good. How do you estimate the cost for CDN? The cost estimates are, I think, purely via data transfer, the amount of data transferred. We can look at the cost in a second for that. But it's actually surprisingly cheap for most of your personal stuff. It can get expensive for larger organizations, but it's pretty cheap. Akamai and stuff like that is actually really expensive. Things like Cloudflare are pretty cheap for personal projects and things like that. So, and then your time to live is configurable. Again, you can set it to whatever you want. You can set it to 0 if you don't want it to cache at all, but then that would be kind of pointless. You can set it to, 4 hours, 8 hours, whatever you like. You can set it to whatever floats your boat, whatever your organization likes. And let's look at the pricing for it, because that is a good question, 88 Opus. And you can see here that I have not been studying for my Solutions Architect Pro, because I would probably know pricing if I was studying for it. Let's check this out, because this is one of the most interesting things about AWS, or one of the most annoying things about AWS. So yeah, it does look like it's on both. Okay, so I guess it's on both request and the amount of data that is transferred. So it looks like the free tier, you get 50 gigs of data transfer out free and 2 million HTTP or HTTPS requests each month for 1 year for free. So that's nice. Then on demand, after that, based on the actual usage of the service, so data, the amount of requests, the amount of data, and then you do have to pay for invalidations after a certain point. You get a certain amount for free, but you do have to pay for invalidations. They're pretty cheap. They're pretty cheap, like change for like tens of thousands of them, something like that. Dedicated IP custom SSL certificates. So you have to pay for a bunch of different things here. So it looks like it's relatively difficult to calculate this. Well, not difficult, but you've got to do a couple different pieces. And so you can see the pricing here, on-demand pricing per gig out. So you can start to check your internet traffic and kind of start to plan based on the amount that you have, or maybe that you have an estimated rate of growth or something for the amount of traffic that you have. And I mean, this is actually pretty cheap per gig. So 8 cents for the first 10 gigs. Then 8.5 cents for the first 10 gigs. Then 8 cents for the next 40. So it takes a bit for it to get expensive. Pretty cheap. It's change, per gigs. And then plus things like requests, and then those things will probably possibly go hand in hand, and a few other options here. So that was a good question. All right, back into here. So actually, before we actually go into Route 53, let's go down really quick. Mastermind is actually going through. Pretty sure Mastermind is going through CDN. I can't remember. Let's see. Let's curl. Just want the headers. HTTPS. I'm pretty sure it is. All right, so check this out here. Check out this X cache here. And it says hit from CloudFront. That hit from CloudFront means that that was a weird series of events. Sorry. That hit from CloudFront means that I'm actually getting back cache data. And so you can use this information to know, again, whether or not you're getting data directly from the origin or from CloudFront. If I were to clear the caches, and actually, I think it's in a different account. I don't think it's here, but let's check. Now I can log into the other account really quick. Yeah, let me log out for a second. Sign in. Different account. Can't see because it's tiny. Get logged in. I think this is relatively not important, but cool to see. Logged in, click CloudFront here. So let's say I have two CloudFront distributions here, one for mastermind.io and one for academy.mastermind.io. And so they're basically these things called distributions. And I can click into it. So basically we talk about origins. So you can set up multiple origins. So you can use various AWS. Sorry, excuse me, man. This LaCroix is not treating me well at all. But you can set up different origins here. So right now, all of my stuff is static right now and served out of an S3 bucket. We talked about S3 buckets. We talked about them being object stores. We also talked about them being able to do static website hosting. So I statically host these things out of website buckets. So one of my origin for this is actually an S3 bucket. It's an S3 bucket. I could have things like other resources. So I could have things like EC2 instances or load balancers, or I could have a bunch of different options for the origin in which my data is to go through. And then you set up these things called behaviors. So not only can I determine what the origin is, I can route to different origins based on the location you're hitting my site at. So maybe let's say maybe I was hosting the DevOps curriculum out of S3, but maybe I'm hosting the Python curriculum out of an EC2 instance. Doesn't make any sense, but maybe I am. I could set up a behavior that's basically for like /Python or something. And then every time you went to /Python, I could select a different origin, and CloudFront would use that origin to make the request, which is really nice. So it gives you a lot of flexibility. But invalidations is where you can clear out the cache data. So I'm going to clear out everything just because I could just do /, but I'll copy it. I'm going to clear everything. Now check this out. This should work because unless someone else hits it first. But you can see here, I hit from CloudFront here at first. Now it says miss from CloudFront. So it did not get cache data. It basically, I got the request, but it went to the origin and got the data. And if I do it again, until I clear the cache again, or until it invalidates and I'm the first request after it, I'll keep getting hits no matter what. Because I'm hitting the same edge location over and over again. I could clear it again. And again, that first request would give me a miss and basically say, nope, I have nothing here. Let me go ahead and get the most up-to-date data. And then after that, I will consistently get cache data. So I think that's a little bit interesting to kind of check out. But that's what CloudFront is. Again, it's a content delivery network. It allows you to distribute information from your origins around the world to different edge locations, either around I think the two options you have are around whatever, or either around the US or whatever country you're in, or around the world. I think I have mine set up to be around the world right now. And you know, each of those edge locations will cache the very first request that it gets to it. And it'll keep it for as long as the time to live is set for. Right now, my time to live is set I don't know how many seconds it's set to. It's the default is 86,400 seconds. Don't know how long that is. We could do some math real quick, but I don't feel like it. It is the max CTL. So it can get extended basically by the requests that are made. So this is the maximum amount of time that it'll be available for you. A minimum right here is 0. So have a minimum, maximum. And you get a bunch of other options here, but that is all a CDN is. Play with it. I definitely think it's like you won't cross the free tier for a year, so like definitely worth something. Like it's definitely something that's worth checking out there. So let's finish up the rest of the stuff. All right, Route 53. This is great. Route 53 is a very important service within AWS. This is a highly scalable DNS service. Why is it called Route 53? Route being, or route, however you say it, I don't know. I say Route 53, Route 53, whatever you want, whatever floats your own boat. But DNS 53 is, yes, there you go. 53 is the port for DNS. That is why it's called Route 53. And again, routes are how you get stuff around. And we know what DNS does. We know that DNS is domain name service that translates IP addresses to domain names. So it is a highly scalable DNS service, very easy to use. And so it can scale up with requests. You can manage traffic flow, which is really nice through here. So you can do latency-based traffic routing. You can do geo DNS. So based on you can basically deliver DNS results based on the location of the person, geo proximity, and weighted round robin. So that's pretty nice. But the biggest reason why Route 53 is amazing is because it has these things called alias records to AWS resources. So the way the DNS works is interesting and doesn't always quite work in the paradigm of the cloud because of the way that the cloud references resources. Route 53 allows you to create these aliases directly to AWS services, which is really, really nice. And we'll go on and we'll take a quick look at that. And it also allows you to purchase domains. And if you purchase domains, they also give you free SSL certificates as well. So that's pretty cool. So let's go in and just take a look at that. I don't think I'm using Route 53 right now, but let's log into it anyway. Pretty easy. Hosted zones here. So your zones are going to be for the domains in which you have these hosted zones. And you can see here, we host, I told you guys about the Baltimore Black Techies site that we run. So we run that through here. And the mastermind.io we do have through here. And so you can see some stuff in here. These are all, so we have an alias record here for my S3 bucket. So I'm pointing something directly at S3, which is super nice. This is not something you have the privilege of doing outside of here very easily. Just got some name servers here that are set up by default. But again, remember those records we talked about. Remember we have A records and MX records and all the records that we've already talked about and a few others that you may not know about. But you can go ahead and create those here and set up records. These records have TTLs as well. We talked about those as well. But yeah, it's what you need to know about Route 53 is it is a highly scalable DNS service for AWS. And again, one of the reasons why it's most important in terms of AWS is that it allows you to alias records to AWS resources, which is super nice. And also that it has some traffic flow policies, again, like geolocation, round robin, a bunch of other things where you can control where traffic goes based on DNS. So you can use DNS for like failover. So like if resources and things aren't working, you can actually use DNS for stuff like that, and to be able to fail over to different services. But yeah, it's super nice. It's also great because these alias records and stuff are great because once we get into the infrastructure as code piece, when you are automating infrastructure, when you're automating especially immutable infrastructure that is torn down and spun back up, and when changes need to be made, it's torn down and spun back up and things are moved around. This can become great. This allows you to, these alias records allow you to very quickly point things at new places and automatically apply them, throughout your process. And it's pretty cool. It makes it really, really nice. So just know that Amazon has its own domain name service, own DNS service called Route 53. It's highly scalable. It's got some routing options, and it allows you to point records to alias records to AWS resources. Great stuff. I recommend playing around with that. All right. Now, resource management. This is maybe not be called, this might actually be a bad name for this section. This is a quick two-parter here, and two things that are very important. The only reason we're not going to spend tons of time here is because we have a whole section on monitoring and observability where we'll dive hands-on with some of these things. But again, something I want you to know about so that you can start to dive into these things yourself. So CloudWatch. CloudWatch is very important. CloudWatch allows you to do a lot of things. Again, think about the name, CloudWatch. It gives you some insight into the things that you're using. So what does CloudWatch allow for? CloudWatch allows for alarms. So there are various metrics that CloudWatch can watch and take based on the service that you're using. And they differ across services. Again, for EC2 instances, again, it's some things like CPU, network, things like that that you can watch. And you can create alarms based on these things. So if you want to be alerted when CPU usage is super high, or disk space, things like that, all these kind of different things you can configure a lot. Some stuff comes by default, some things you have to add in. But you can configure alarms to be alerted based on these things. These alarms are cool because AWS is just a giant API. You can utilize these alarms to do things like get sent automatically to Slack or emails, all kinds of stuff to be alerted. So that is great. You can utilize CloudWatch for logging. It is I don't say notoriously difficult, but because of the way the cloud works, because of the churn of resources that you may have within the cloud, logging and log aggregation can be annoying and can be a little bit difficult to manage. So you can set up these things called log groups, where your AWS resources will deliver their logs to, where you can quickly find them. And we're going to hop into the console in a second to take a look at that. Then there's these things called events. So these are basically crons. These are basically scheduled jobs that do certain things. So you have these events that can kick off jobs, that can kick off lambdas, that can kick off all kinds of stuff inside of AWS. Again, there's a scheduled event that happens that you can do some cool stuff with. Then you can have stuff like billing alarms. If you want to, if you care about, you should care about how much your stuff is costing. You can set these things up here. You can also set these up in the billing section, but billing alarms you can set up in CloudWatch to make sure, once I get to $50 a month, let me know so I know not to do anything else, or that I can take action. And then monitoring metrics. Again, finding out information about your services and kind of how they're running. You can see these things in here. So you can send all your AMI logs there. Yes, you can send all of your AMI logs to CloudWatch if you like. And by AMI logs, I'm assuming you mean your instance logs, after it's deployed via an AMI. Yes, you can have them sent there. I think they go there by default as long as you send them to syslog. If you're routing whatever logs go to syslog, I think by default will end up here. I'm pretty sure if you have it set up, or if you're running right, yes, they will go there. So let's take a look at CloudWatch. And again, CloudWatch can be a little interesting because it has so many sections. I would say the dashboards that you can create for monitoring is probably, I didn't actually set these up, I don't think. Or maybe I did. Maybe we set these up last time. We're trying to create a quick dashboard, which has nothing. You can basically create a bunch of widgets, like your own dashboard that like look at different things. So again, like EFS and S3 and like you can create your own dashboards here and it'll have a visual. You have a visual setup of what things look like. I don't really use this for personal stuff. Don't really need it, to be 100% honest, but all good. So dashboards are great. That's your monitoring and metrics. Alarms here. I have one red alarm. Let's check out what this is. Billing alarm. Estimated charges are greater than $25 for one data point within 6 hours. So is this an active alarm right now? Probably, because we started spinning up random stuff. Last change 2/14, so Valentine's Day. So you can see here, you can have an alarm and it alerts you. I'm sure it sent me an email as well. That's great. And then it'll just let you know other things you are taking a look at that you are watching, but that are not alarming. So that's really nice. CloudWatch Alarms is nice. Again, billing, so you can set up your billing alarms. Logs. This is where you set up where your logs go. So I actually don't have many logs set up because I actually don't have any servers that are running. But this is from our lab last time. I will delete these before we get to our lab this time. The serverless lab is different. It is actually different, but you can see here, they're kind of annoying to parse and read. There are better ways to aggregate them and read them. There's AWS log tools and stuff that you can use, but you can see here that this is a Lambda, so this has a bunch of extra stuff in it that you may not care about. But you can see I saw an error in here. We got a type object, none type object is not a scriptable thing here. So yeah, so you see logs get sent here into these log groups. You can end up with a ton of them, which is super annoying. They can be tough to parse. There's definitely an art to it. If you can use it, I mean, this is a go-to tool because it's free and a part of AWS, but I think there are other good tools like Papertrail and some other log aggregation tools. Maybe if you had an elk stack or something that you may maybe make it easier for you to kind of consume these things. Metrics, again, these are if you want to just check various metrics for different services. You can set that up here. Events. This is where you can set up crons, basically. You can create a rule that does something on a schedule or an event pattern that can be triggered, but you're basically creating a job that happens, again, based on either schedule or some type of event pattern, which is really nice. Generally, these are used to, again, kick off jobs. So maybe if there's a nightly job that I have to back up everything on my server or something, may kick it off via this, or to trigger a Lambda, or like there's a bunch of reasons why you would use these CloudWatch events, and the rules are the things that specify what actually happens when these things happen. So those are nice. So again, if you ever need to schedule anything, that is what you would go to. Then everything else we're not going to talk about. None of this is super crazy important. The kind of top section is what you probably want to care about for now. But that's what all CloudWatch is. And let's get into the very last thing, which is CloudTrail. So these are both of these two things are both used to gather information. CloudWatch generally is to gather information about your services that you're using. But CloudTrail is a little bit different. It's an application program interface, so API, call recording and log monitoring web service. That's a lot of words to say. What this does is this watches API calls to Amazon. So I'm pretty sure early on I told you that Amazon is actually just a giant, it's software. It's an API that sits on top of physical infrastructure, basically. And so what CloudTrail does is it's basically watching the user interaction. It's basically watching API calls that are made to Amazon rather than services that are running. And so again, this is how you can, do some forensics, some tracing on who did what. Like using CloudTrail, you can see, who submitted the API request to spin up that last EC2 instance, who did, who created the S3 bucket, who grabbed data. So yeah, CloudTrail is really nice for, tracking user activity and API usage, to let you know what's going on, kind of on a user level, and it lets you know like the event time and what access key created it, and was used to do these things, which is really nice. Why would you would only need to use this, again, if you are the kind of account administrator. And again, if you ever needed to reference, if something was going on and you're like, I see someone made a change here, someone updated this or did this, and you need to find out who did that, or track that information for compliance reasons or whatever, CloudTrail is how you do that. And it's, I don't know, it's cool. it's fine. I don't love it. You can send these things, you can send these trails into S3. I think you can also send a trail into CloudWatch, I believe, but you can definitely send them to an S3 bucket if you set up these trails, which is nice. So if you don't want to have to go parse through here, you can put them in an S3 bucket. And again, you can consume them by another service. There are services like X-Ray and Athena inside of Amazon that you can use. There's other things like, again, like Papertrail or Elk Stacks or something to be able to consume and parse this information if you need to do those things. But that is, that's all CloudTrail is. It is very simply just an API call, like history viewer, so you should know what can happen. So that you can find out what happened. But that's it. That is it for that's all we got. Again, the main piece of this was VPCs. So let's do a quick tangible takeaways, and maybe let's do a quick rundown of what we've learned so far. Let's see, Afrocoder. If you're going to use your AWS account, take some time to set up your CloudWatch billing alarms. I forgot to terminate some instances and my account free tier period expired, and those fees rack up real fast. Absolutely. If you are going to mess around with AWS, that is great advice, Afrocoder. Again, how do you set those things up? How do you set up those billing alarms? That is through CloudWatch. And you can check that out. They were nice enough to credit me 2 months of fees. Absolutely. If you ever make the mistake, do reach out to AWS support. They're usually on your side. So reach out. But you can set up these billing alarms to make sure you can get alerted if you are crossing whatever threshold you care about. Even if it's $1, if you want to make sure you're free, set it up. Definitely go in and set it up, and that'll give you your first inside AWS, and that's something you put in your resume immediately. Say, hey, I know CloudWatch. Like I've been diving into AWS, now I understand CloudWatch. Perfectly reasonable. These are things that you set up. This is a real thing that you would do on your job, is to set up an alarm or set up a bunch of alarms based on billing in there. But all right, tangible takeaways. What did we learn tonight? First, tonight we learned about VPCs. VPCs are what? They are virtual private clouds. They are isolated pieces of private clouds in the entirety of the AWS public cloud that isolates AWS resources for you. And we learned that those have a bunch of different pieces to them. Things like internet gateways, which allow public subnets to be able to access the internet, and vice versa, allow the internet to reach through a public subnet to be able to access information. We learned about NAT gateways, which allow private things that are in a private subnet to be able to reach out to the internet. So again, things like updates, if you want to update your server or be able to download something to a server, but it's not a two-way thing. It's a one-way thing by default. You have to explicitly allow it to do more than that. We also learned that VPCs, because they're a little isolated section, they do have a feature called peering. So if you want to have resources in your VPC be able to connect or speak to or transfer data to items in another VPC or to another VPC, you can peer two VPCs. You can take two VPCs and you can put a peering connection between them, and that will allow data transfer between them. And again, two VPCs have to be explicitly connected for them to work. They have no transitive data passing, so you can't have A, B, and C in the middle, and both are going to C, and you can't send data from A to B just because there's a connection in the middle. Doesn't work like that. We also learned about CloudFront, which is that content delivery network that Amazon has. Content delivery network have edge locations. Those are servers. Those are locations around the world, geographically distributed locations around the world, and requests are made to the thing that's closest to the edge location that's closest to the user, and those edge locations cache data from your origin, from whatever you said is the origin, and so they'll cache the first request that's made, and they will deliver that cache content until the time to live has expired. And again, so it'll make one request to your origin, and then it will simply serve that cache data until it expires, or until you manually clear the cache, which is called cache invalidation. We also learned about CloudWatch, where we could go to do a bunch of things like setting up alerting, setting up alarms, where we could have some monitoring and observability into our AWS resources, so we can kind of know what's going on. We can set up dashboards that monitor certain metrics like CPU usage and things like that. We can set up alarms based on that usage, so that we have some information that we can be alerted based on over usage, too much memory, too much CPU, too much whatever, too much traffic. So we can be alerted. For that, same thing for billing. We know that logs can go here. We can get log information sent here. And then we have these things called events that we can use to either schedule actions or be reactive based on actions that happen. And these rules usually kick off new jobs or cause other things to happen inside of AWS, which is pretty dope. Then we learned about CloudTrail, which is basically a forensics service. It's an API history service that Amazon provides to you, so that you can see who's making API requests and who's doing what inside of Amazon. It monitors your users rather than your services. CloudWatch is for your services. CloudTrail is really for your users, to kind of find out who did what and keep track of who did what. All right, so that's a lot of stuff. That's a whole lot of stuff here. But over these three parts, we've covered a small sliver of the, again, so I think someone said there were 177 services, or 127 or 177 services. I don't know, bunch of Amazon services. We've only covered a handful. Maybe we've covered, 10 or so of the main services, so the core services. So again, we covered things like IAM, which is very important, which manages user and service, what they have access to, permissions and access. So IAM, which is identity and access management, very, very important service. We covered EC2, which is your generic virtual machine service. We learned a lot about that. We learned about S3, which is we ran through some storage options, your simple storage service, and EFS, which is elastic file system. So we learned about network attached storage. We learned about the storage that backs EC2, which is EBS. So that's block storage as well. What did we learn? What did we learn last time? Let's see. I think we went over storage last time. We learned about RDS. So we learned about the database options that we have available to us. And that's a managed database service, which is nice. Even though we can install databases manually on EC2 instances if we'd like, we went ahead and we knew that we could use RDS to do so, which is great. We learned about DynamoDB as well. So we learned about relational database stuff. And then we learned about NoSQL stuff, which is not only SQL, things like DynamoDB. We learned, and then today we learned about, again, all the things that we've already covered so far. So a small sliver of what AWS has to offer, but hopefully it's enough so that you feel comfortable enough to like hopefully you've touched enough services, whether or not you really get them or not, to feel okay clicking around and going through some tutorials and starting to dive in. And hopefully you're starting to see how all the services just, again, provide a solution to one thing, and you have to find the service that works for whatever your solution is, and you use that and you build that into your solution. You just pick all the pieces that you need and you use that to create one giant solution, basically. And a lot of the services are very similar, for sure, and different services can all serve the same need, again, just in different ways. So there's not always a perfectly right answer for these things. Like, you take what you know at the time, you do as much research as you can, and you start implementing solutions with these things. But you don't need to know every single service. You do not need to know every single service. Again, there's a group of core services, and I think we went over a lot of the like super core services that you would probably get asked about in an interview. And then over the rest of this, we'll touch more and more of them. So things like ECS and EKS, we're going to be touching things like that in ECR. These three, so like either compute stack, like everything kind of above here. We're going to touch Lambda on Tuesday. And so we'll basically know all of these things. And then you probably won't get asked about any of this stuff. We learned about all these. We've already learned about basically all this stuff that matters. We learned about just these two, but that's fine. Like, you can dive into these if you want, but these two at the top, probably all that matters. We learned about Cloud Trail. We're going to learn a little bit about CloudFormation. We learned about CloudWatch. So there's a bunch of stuff. You don't need to know them all, but again, just trying to help you dive into some of the core services. And so I am doing the next iteration of boot camps, which will be in May. These finish up in March, at the end of March. April is going to be a bunch of smaller workshops, and then at the beginning of May, I think we're going to do a Golang, like a higher level, like a mid-level coding bootcamp with Golang, to kind of serve. There's definitely a middle ground that people have been asking for a little more in-depth software engineering section. So probably that, and probably a full cloud boot camp rather than this DevOps boot camp, and then we'll probably do a more advanced DevOps boot camp for the last set. Basically, there'll be 3 12-week sessions throughout the year. So just a little foresight on what is hopefully coming up, but more information will actually be coming out very soon about that, because actually planning on, haven't really advertised any of these things, but probably going to advertise the next run through of boot camps pretty heavily. Actually probably going to be putting a significant emphasis on deeper, like weekend, workshop sessions. So again, diving deeper into some of the things that we don't get to dive super deep into. Like a lot of the things that people have been asking a lot about are containers. So maybe doing like the first one I'm planning is like a weekend, like a 4-hour Saturday and Sunday, or maybe like 6 hours with a break in the middle, like deep dive on Docker, and doing that every so often, like with other technologies. So, much deeper dive into CI/CD. So really diving into Ansible, taking, a bunch of hours to really dive into Terraform or to Kubernetes, things like that. So just information on what's coming up. But what we'll be doing we're into the fun stuff now. Like starting on Tuesday, to me, this is where you'll start to see all the stuff is important. All the stuff is fun, but like coming from a traditional sysadmin background, I think I actually gravitate towards these faster moving, development focused things, because I've never seen, I guess traditionally I've never seen speed like this. But we're going to dive into an AWS lab, Lambda lab. We're going to be using the serverless framework to basically be able to build out applications without a server, and kind of just understanding what that works. It's a misnomer. Serverless is not really a thing. It's definitely a misnomer. There are always servers, but to you, there's no server. So we're talking about that, and API gateway, and learning a bit about APIs, because that's important. Then everything that we've done manually so far, we're going to learn how to do it with code. So we're going to be getting back hands-on with code, and we're going to be using Terraform to be able to create the same way that we created this VPC by hand. I'll show you the way that I'm used to doing things now, and configuring it via code, which is super nice. So we'll do Terraform, then we'll dive into a little bit of Ansible as well. So we'll spend time with Ansible. Then we'll do 2 parts on containers. So Docker 2-parter. Then we'll do orchestration 2-parter. So Docker 2-parter, Kubernetes 2-parter. So hopefully you're excited about that. I think that's going to be very fun. Get you ingrained in the Docker because there's a lot of stuff there. Then get you high level push into Kubernetes. And just container orchestration period. So we'll be going over like Docker Compose and stuff, like how do you do basically containers at scale. CI/CD, which would be super important. This will be something all of us will be doing on our, if you want to be a DevOps engineer, you'll care about that a lot. Monitoring and logging, so it'll get a little boring again. Not boring. We'll be using real tools and stuff and setting up real tools, but in comparison to this stuff, I think this is going to be boring. And then we'll get into the real world, ask questions, learn, from real engineers, like what's going on, hear from other people besides me, which I think is very important to hear and to talk to other people besides me. And that's what we'll have, and learn how to conquer the DevOps interview process. So that's everything that we have. Tonight was a short night, good night. That was good. We got through the AWS stuff. That's a big portion. So if you have any questions, feel free to reach out. I would recommend, if you're looking for a leg up, I generally don't recommend, what's up, TCXO? I think that's what I saw. I think I missed that. I forgot to say thank you for following. What's up, whatever, Gyro? Welcome. Thank you for the follow. I will say I don't usually recommend certifications, but in the industry right now, these do seem to be, AWS certs do seem to be valuable right now. And so I do think if you're trying to dive into this stuff, I would recommend, checking out some of the AWS certs, do some research on it first. There are 3 associate level AWS certs. There's a cloud practitioner one. You can get that if you want. It's a little bit cheaper. It's a little more intro. But if all this stuff went way over your head, feel free to start with that one. There are 3 associate levels. There's a solutions architect, there's a developer, and there's a sysops. A developer is probably the easiest, followed by solutions architect, followed by sysops. The reason that is because they've had sysops be for kind of the hands-on, like precursor to like the DevOps professional cert. But from my experience and what I've seen about it, it has a little more. You have to have like. It relies on you having had some industry knowledge more than the other 2 per se. The developer one is pretty simple. They basically there's a lot of DynamoDB stuff on there, but it's not as broad as like the solutions architect. The solutions architect exam is pretty broad. The sysops one is also broad, but it's a little more narrow, but it's a little more, the questions and things are a little more ops focused. Like you need to have a little more, I guess, live computing knowledge, I think, to be able to effectively pass that one. Some of the stuff is a little bit tough to study for, but that kind of switches when you get to the professional exams. There are 2 professional exams with a few specialty exams. There's there's a Solutions Architect Pro, which is the hardest exam, and the DevOps Pro. There are only 2 professionals. The DevOps one is fairly focused on a few services. It goes real deep on the kind of DevOps pipeline services that are in Amazon, whereas the solutions architect is much more broad, many more services, but it's a lot more focused on creating solutions. So things like pricing, cost evaluation. It touches so many different things. It can be a bit to study for as well. It can be kind of tough to study for. So I would check them out. Again, not a requirement, but if you're looking for something to give you a little bit of a leg up, I do think studying for them is helpful. I think the information from them can be valuable. You can't stop there. I don't think just studying for an exam will make you great at AWS, but I think it will give you the context and it'll give you enough information to start working with when you do when you are actively working inside of AWS. So that is that, but that's all I have for anyone tonight. That's all I have. Let me know if you have any questions. I'm sending everyone over to the Prime again because I think we went over there last. Only reason we're sending over the Prime again tonight is because he's back to Vim Royale, and I'm very interested in watching the Vim Royale stuff. And again, I think that what he's doing for specifically that series may be valuable to a lot of people here if you feel like sticking around. If not, no big deal. Cloud on Fleek says that, there's a lot of overlap in all three. There is a ton of overlap in all three. You do not need to spend the equal amounts of time studying for all three. If you take time to study for one, you have about 70% of the information for the other two, to be honest. But there's some specific things that you dive into for each of the other two. Tons of overlap there, which makes it really nice, but also makes it really deceiving. Like when I first studied for one, I went and took the developer cert, and I almost got 100 on it, and I finished it in like 15 minutes. And then 3 weeks later, I went and took the solutions architect associate, and I mean, I got like a 72 or 73 without studying at all, because there was so much overlap. But they had at the time that I took it, they had a bunch of questions about elastic beanstalk, which I knew nothing about, which was very interesting. It was really annoying. I think I would have passed the current one from the test questions that I've seen. I think I would have passed that one, no problem. But yeah, I didn't know. But there are tons of overlap. But cool. Good night, Adam. Everybody have a good night. Yeah, we're going to Prime again. I'm going to stick around while I'm going to be working on some things personally over here, but I'm going to be online watching the Prime again. I learned a lot from his channel, especially his Vim Royale series. So let him know I said hi, and I will be there. So we're going to head over, see everybody on Tuesday. Oh, tomorrow, if you're interested in Python, what do we have tomorrow in Python? We have... we have actually there's modules, errors, handlers, and file operations. So tomorrow we're going to be learning how to use basically import statements, how to handle errors, and how to manage files, do some file management operations, writing the files, saving files, and things like that, so that we can add some more functionality into our code. So that should be exciting. Tune in tomorrow if you're interested in any of that. Let's go ahead and raid the Prime again. Maybe I'll get his name right this time. Alrighty. Also, I hope anyone who is off tomorrow get some rest. Again, I'm excited about that. I completely forgot that we are off tomorrow, so this is going to be nice. Prime again. Cool. What? Flash raid. Spelled it wrong again. The PRIMEAGEN. All right, you're heading over in 9 seconds. Everybody have an excellent night. Thank you for joining this site. Oh, also everything is going up on all the streams from last week are going up on YouTube right now. They rendered out earlier today. I'm uploading them to YouTube right now. So if you're someone who's trying to catch up with something, they'll be available right now or just in a little bit. We have some pretty fast upload speeds here, so it'll be pretty quick. But everyone have a good night.